So in the last video, I talked about different topologies of filters. So that was the cascade versus the ladder filter. In this video, I'm going to talk about the different types, which goes very close hand in hand with the topologies. And two of them I've already talked about already, and that's low pass and high pass filters. So if you remember the graph, we had amplitude, and we plotted it against frequency. And for the rest of this video, I'm going to shorten that to A and F respectively. So a low pass filter would give you something looking slightly like that, where you have your cutoff frequency somewhere around here, and then you get your slope off for all where you're starting to cut out high frequencies and you let the low frequencies pass through. The other one we've already spoken about is a high pass filter, which is very similar but in the sort of opposite. So instead of having it pass the low frequencies, it cuts them. So you end up with something more like that, with your cutoff frequency again around about there, leaving you with your high frequencies. And that gives it a slightly more nasally sound. But there are two other main sorts of filters. There are more, but these are the main other two you would encounter. And that is a band pass and a band notch. So with a band pass, it's similar to low pass and high pass. So you're letting a certain frequency band through the filter. So that would appear something like this, where you have two cutoff points, one on the low end and one on the high end. So this is your band that you're letting through, and you're cutting this part of the lows and this part of the highs. Then a band notch or band reject is again the sort of like the opposite to this filter, where you'd have again a high cut and a low cut, but in reverse. So you end up with something more like that. So you're cutting out this band in the middle and leaving you with the low part and the very high part as well. And the way you can sort of lay this out is, if we go back to the basic low pass and high pass filter, a low pass, you've got your input going through a resistor to your output, which is tied to ground by a capacitor, like so. Then your high pass, you have your input going into the capacitor this time to your output, which is then tied to ground by a resistor, like so. Now, a band pass, it is essentially just, as you can see here, you've got your high cut and your low cut. So if you just do one then the other, then you end up with your band pass. And that is essentially how you would structure it. So you would have a low pass or a high pass. The orientation doesn't really matter for this example, but we'll put the low pass first. You have your low pass filter, and then ideally you would buffer it, but I'm not going to show it in this example. Then you would run your output from your low pass directly into a high pass filter, like so. And that would be a basic band pass filter with just only 4 components. the way you would then do a band notch or band reject filter is slightly more complicated, but that's only because of how it has to be laid out. Because what you're essentially doing with a band reject is you have, again, your low pass and high pass, and if you imagine you were to cut your lows further over, so you had it, say, here, for example, and had your cutoff point here, and then cut your highs further over as well, about here. When you mix these two signals together, you would then end up with this part and this part of your signal being mixed together, which would result in your band reject filter over here. So to do that, though, it's not the same, or you can't run it in series like I'd shown earlier. You have to run them in parallel. So you'd have your input running again into your low pass filter, like so, where you would then have your output, but at the same time it's also running through a high pass filter, which would then look like this. Which then gives you a band reject filter. So, and that's basically the principle I explained to you just a moment ago of overlapping your high pass and your low pass at the same time to then get a band notch. But that then led me on to the beginning of designing my own filter, because I wanted to be able to access all four of those different types of filter all inside my one single idea. And I'd like to note as well with my idea, as I talked about in my last video where I talked about the topology of filter, the resonance path of a cascade filter is more versatile, whereas generally the actual filter curve and control of a ladder filter is much nicer and more accessible. So I wanted the filtering of a high pass filter with then the resonant, not a high pass filter, sorry, a ladder filter with then the resonance of a cascade filter. So my initial idea was just to take the first stage of a cascade filter and then use that as an input for the resonance coming off of where you would take the resonance on the ladder filter. So in essence, I've taken just the two filters and just cut them together where I can. And I was able to test this in a circuit simulator, and initially the resonance wasn't working. And I realized the reason for that is because when you bias your input signal for the ladder filter, you also have to reduce the actual amplitude of it. Otherwise, you can risk clipping, and it's because of the curve of a diode that it produces when plotted against current and voltage. You can end up with different responses for different amplitudes of your signal. So you want to try and keep it as tight together as possible. And I realized if you then just take the resonance from after the amplifier in that circuit rather than just before, you then end up with nice working resonance with your ladder filter. And this started as the basics of the filter I went on to design, because I chose, whilst this filter did work and it did most of the things I wanted it to do, I felt like it was still not fully teaching me as much as I could, because I had essentially just copied two filters and put them together. So I do go on to try and develop this filter a bit further, which you will see later on. But something I'd like to talk about, because when I was on about topologies, I only talked about the low pass version of a diode ladder. The way you would make it a high pass version is, instead of connecting your signal directly to each end of your diode ladder, you would connect it to the center capacitor. And then that would give you your high pass filter. And to then get a band pass, you would have, just like your low pass here, you have your biased signal going into each end, but you would then also connect it to the central capacitor like in a high pass. And that would give you a bypass, but it wouldn't be at the same order of the individual low pass or high pass. But that concludes where I got up to with designing, or with planning out my first filter and where I intended to go with it from here. So in the next video, I will go on to explain more how I tried to develop and make my first plan for a filter more unique and teach me more about various circuitry and components.